welcome to another edition of Patio Productions, where we are doing our pre-calculus from Mrs. Fox's patio, which is a little soggy today, quite frankly. That's okay, we're surviving. So what we're going to do is we're going to do another short video just reviewing the major concepts in sections 5 through 8 for our chapter 13 on series and sequences. And so let me get this baby pulled up and we can get right into jamming. Your assignment is going to be doing it's really hard for me to click and think at the same time, guys. Seriously, multitasking. I can't do it anymore. We are going to be just working on the fast track concepts. So remember for fast track, it's just a lot of questions. It's just kind of like a review assignment, and the answers are posted for you guys to consult, but really you're just going to pay attention and just think about the different concepts which were in this second half, right? So we're gearing up to finishing up this week, and then after spring break, we will do some quizzes and stuff, and then we'll be ready to take our test on the Friday after spring break. So I hope you guys are getting all situated and golden, and so let's review some concepts. So one of the things that was in this half of the chapter was binomial expansion. So I'll ask you to take something and then they'll raise it to a certain power. It'll just be a binomial. It could be something as simple as x plus y and then to a power, or they could even put something complicated like, 4x minus 3y to the, to a power. And so one of the ways that we would do it is it says to you could use, if they ask you to do the whole expansion, you're probably going to utilize Pascal's triangle to get the coefficients of each one of your terms, right? And so if it says, let's raise something to the 5th power, then you would use this row right here because the second number is a 5, and the coefficients of all your numbers are 1, 5, 10, 10, 5, and 1. The other thing is if they ask you just to get one particular term, if they ask you for one particular term, remember every term is of this form where it's the first guy raised to a power, the second guy raised to a power, and then the factorials. This factorial on top right here is the total number, whatever you're raising it to. And then these two numbers right here and right here are the exact same numbers as these coefficients with their factorials. Remember, when you're putting this into your calculator, you got to do parentheses around the denominator to make sure that it comes out good. And then if there's any other numbers in here, like a 2a, you have to raise that to the power. Things that I like to do for this guy right here is I like to just count things on my fingers. Sometimes they'll say, write the term with a specific exponent for like the x's, like x to the thirds. And so you'll fill that in. Or maybe it says like the 6th term or something like that. And then I just like to count it off, right? I'm like going down and decreasing powers for this guy right here to figure out what this first power should be. One more fun fact is that these two powers put together will, in fact, add up to whatever the total power is that you're raising your binomial to. I know, good stuff, good stuff. I think that you felt like that this assignment this section was pretty snazzy, so hopefully you'll be super successful. Then we got into things about sequences, okay? Does the sequence converge or diverge? There is actually a lot of strategies for these. You're looking for if the terms are heading towards a target number, maybe it's wise to write out some of the terms or maybe even to graph them, or even just imagine what the graph would look like. You know me, I'm always a fan of drawing the pictures. So maybe it's just a matter of like, are my points going towards a number? Are they, gearing up? Are they just getting larger so it diverges? Are they doing stuff like that? Sometimes what happens on these guys is we have oscillating terms, but I want you to just think to yourself that oscillating doesn't automatically mean, so when it's oscillating, okay, oscillating does not automatically mean that it diverges. So you really got to think about like what the numbers are actually doing. If they're oscillating but coming in towards like a target number, kind of like almost wedging themselves in, then that would be a converge section. If they're oscillating like at the same levels, like, oh yeah, then that's definitely diverge, because you want your sequences to be coming to one particular number. Now that number could be like a 1, it could be a 2, it could be a 0, it could be a 10, but as long as they're coming in towards a number, then that means it converges. Okay. We also talked about, does a series converge or diverge? Okay. So a lot of times with our series, you have to like figure out what they look like. Sometimes they're in sigma notation, right? And then sometimes they're expanded out. So you got to think about both of those. If it's a geometric series, it's kind of actually easy to figure out. You just look at what you're multiplying by, that common ratio, and is the absolute value of that common ratio less than 1? And if it is, then you know that it converges, and you can actually figure out what it converges to. Okay. What it converges to is it's actually a little bit later in this the highlight section here. So it's S equals the first term a sub 1 over 1 minus r. Another thing that they ask us to do is to write repeating decimal as a fraction. And what you would do is you turn the repeating part into an infinite geometric sum, and then you find your first term and your common difference, not common difference, excuse me, JK, your common ratio, and then you're able to put that part into the equation right, where's my little mousey mouse? You're able to put it into this equation right here, and then there might be some other terms in the front, like a 7 or a 10 or something like that. Okay. Then we talked about power series. Okay. So when you look about a power series, you got to look at what's being multiplied each time, like what is being increased in power. That's what you're looking for. And when you do that, it might ask you for what values is this power series convergent. So you just make whatever that is, say like you're multiplying by, like every time you're multiplying by a 1 plus x, or every time you're multiplying by a 4x, or whatever it is, then you're just going to put whatever that is. Ouch, I hit my patio table. Shouldn't talk with my hands so much. So sorry. You're going to put whatever that is in absolute values, make it less than 1, and then you do like the sandwich where you put -1 and +1, and then go from there. Okay. Additionally, it might ask you to find a power series that converges to a particular function, and they're going to give you that function. So they're going to give you some sort of a function that looks like this or something like this. If it doesn't look exactly like this, what's really important is getting a 1 in this spot. And if you don't have a 1 in that spot, go ahead and like factor something out and then put that extra number in with the numerator. And then basically it's just a matter of pulling the numbers, just pulling the numbers. This a sub 1 is just going to be this a sub 1 right here. And then whatever this common ratio is right here, you just put it here. For these guys, you do the sigma notation from k equals 0 to infinity and do it as a power of k right there. Very, very, very simple. Okay, there's the classic ball bouncing word problem that we love so much. So that first drop is not included in your calculations. You kind of separate that out. You probably should draw a sketch, and then you think about modeling it as an infinite geometric sum without that first drop. And just every other bump is going to be like something times whatever the percent it pops up at, like 70% of each time, or 80%, or whatever that might happen to be. I know, very simple. And then there was these extra questions where it says express a complex number in this r times e to the ix form. And if you were doing these and you felt like a little bit deja vu, you were totally right. It was a kind of like a throwback to doing polar. And so you find the r value by using the Pythagorean theorem. And then I like to just find the x value, which is the angle. They could have also put theta. I like to just draw a picture. Sometimes it's famous angles, not sometimes, like lots of times it's famous angles. So you just draw your picture, and then you're able to figure it out. And it's a matter of just plopping the numbers in. Like whatever you get for the r, you plop it right there. Whatever you get for the theta or the angle, you put it right there. And then you're done. Like that's literally all there is to it. I know, like so simple and straightforward. Okay. That is it. That was a very quick review. And so I'm giving you, again, 2 days to get these questions done because there are so many of them. Work at your own pace. I already gave you an answer key of the answers written out. If you're like, Mrs. Fox, I did not understand how you got that answer, come talk to me during office hours, of course. You can also work with your friends on this, right? Because it's just a matter of getting it done. And so, again, I really hope that you are doing a good job getting your stuff turned in, folks. and just keeping up with the work, because again, we are going to be taking a test on this after spring break. So we'll do more review after spring break, and then it'll just be let's hammer it down and let's go to get some test points in our grade. You know what I'm saying? So a lot of us want our grades to be improved, and I hear you. So let's get some test points in there. So more details about that test will be coming up after spring break. But yeah, let's get it done. All right, guys, fanfare music to exit us out of here. I hope you have a wonderful day. Enjoy your time doing pre-calculus. Bye.